street, right? This is y, and let's say this one is your x. So you have to calculate y divided by x. How can we calculate? So how will we solve this problem? So right now I told you if this is a closed loop transfer function, right? So how can I calculate? How can I solve the transfer function of this closed loop? Directly can I write in place of this there will be a GA, and for this I can write that multiplication of these things GAGC, sorry, GBGC divided by 1 plus, if there is nothing, so 1 is there, so that is GBGC. So transfer function of this loop is like this one, GBGC upon 1 plus GBGC. Is it clear? And then again this is y and this is x. So y by x will be the only multiplication of this one. So y by x is equals to GAGBGC divided by 1 plus GBGC. Is there any doubt? Tell me. Anyone has any doubt? Okay, so if there is no doubt, then we will solve one more question over here. So let's say there is GB, right? After that there is GC, right? There is transfer function over here, right? Here there is GA, right? And this one, oh sorry, This is last transfer function that I'm solving. I mean closed loop transfer function that I'm solving now. You have to solve by yourself only. So this one is there, and yeah, this one is your x, that is your input, and there is this kind of thing here. There is transfer function gc divided by ga, and that is going here. That is again positive, and yeah. So this is ga, this is y. So we have to calculate the value of y divided by x. Fine. So how can I calculate? So let's try to understand one thing. How will I solve this problem? So since this one is x, I am just using my basic method again. So this is the best method. I hope you understood this thing. So if this is x, so again this one is x. Again here x into, can I write gc upon ga? So here it will come here. Again here, if it is x, x is coming here. So here what happens? Let's say I will be naming here. That is a and that is b. So what can I write? A is equals to what? GB into X. And what is B? B is equals to A into GC. And we have calculated value of A. So can I write GB GC into X? Now it is coming. And what is, let's say this one is D. So what is D? This is the best method, that the way I am solving right now, because there will be a very less probability to, do any uncertainty or any mistakes while when you solve this by this method, right? So D is equals to what? B plus this one, right? So B plus X into GC by GA. And we have calculated value of B over here. So D is equals to GB GC into X plus X GC divided by GA. And what is Y? Y is equals to, Darshana, tell me what is value of Y if this is GA. Anyone? What is Y? Y is equals to D into GA. Am I right? Y is equals to D into GA. And we have calculated the value of D. So Y is equals to GB GC into X plus X GC by GA into, there is also GA, right? So Y is equals to, you can see GA GB GC into X plus X GC, because GA GA will get cancelled out. Y is equals to, I'll take common X, so that is equals to GB GC GA plus GC. So the aim is to calculate Y by X. So Y by X is equals to GC plus GB GC GA. Is it clear? Tell me. Anyone any doubt? This is what we are supposed to calculate, right? So your Y is your output and your X is your input. I hope this thing is clear to all of us. So anyone has any doubt, please ask me right now. If there is no doubt, then try to solve one problem. This is 3, this is 2, let's say. This is 1, fine. And there is a negative feedback over here. Negative. There is a positive, fine. There is a comparator, fine. And here there is a 4. Again here 1. That is positive also. That is also positive. That is 1 by 4. And here I am taking y output. Or you can say this one is 1, 1. This is your y. This is your x, that is equals to 1. X is equals to 1. So calculate the value of y. What is y? This one is 4. This is the last problem that I am solving by myself. So now you please try to think and tell me the answer as soon as possible. Anyone at all? I don't think why you people don't reply. At least if whether you are solving or not, you should reply, na? So again, this is very easy. So I told you if there is a multi-loop, then first we'll solve this small loop. So what is the transfer function of a small loop? That is 2 multiplied with 1 divided by 1 plus 2 into 1. So that is equals to 2 divided by 3. So then this loop will get vanished and this loop will look like this one. That is 3. There is a comparator. There is 2 by 3. Fine. Fine. There is a 4. After that, this one is there. This one is y. This one is your input. Fine. Now there is 1 and your input is there. This one is x, right? This one is positive. So if it is positive feedback, then what will be the transfer function of this one? That is y divided by x. That is multiplication of all these 3 into 2 by 3 into 4 divided by 1. If this is positive, then here this is minus, right? Minus 3 multiplied with 2 by 3 multiplied with 4 multiplied with this 1. Is it clear? And x is also 1. So y x is 1. So that is 1. That is how much? 3 and 3 will get cancelled out. So 8 divided by 3 and 3 will get cancelled out. So 1 minus that is equals to minus 8 by 7. So the value of y is minus 8 by 7. I hope these things is clear to all. Anyone has any doubt? Rakesh, do you have any doubt? Are you here?
Sir, hello, sir.
Yeah.
Sir, in this loop, we have positive feedback, no, sir.
Yeah, here this is positive
So,
feedback. Here this is negative feedback.
so x
So
plus 1 will be equals to y, no, sir. Overall in loop rules.
x plus
1 will be equals to y, no, sir.
x
Means
plus
we
1.
will solve accordingly through loop means.
Yeah, so here it is. Here y will be there, na? Y into 1. So here this is y. So here this will be x plus y.
Yes. Yeah.
Again, again it will
Okay,
be
sir.
into. Are you getting it? In negative feedback it is x minus, but it is positive feedback, that's why it is x plus, right? And after that you can apply the basic thing. But here there is a negative feedback in this loop. This is loop second and this is loop first. So in second loop you will see there is a negative feedback, or in loop first there is a positive feedback, right? So you will have to work accordingly. Any doubt? Is it clear, Rakesh? Okay, if it is clear, then I'll move forward towards some controller. So when we talk about the controller, so I mean, yesterday I have discussed about some, what's the work of the controller in the process, right? Why do we use controller, right? Can someone tell me? Yesterday I told you, no, why do we need controller for the control system?
Control the error, sir,
Control
or
the
for
error.
getting
That's
the
it.
digit.
So since this one is your, just wait 1 second. I'll have to plug in my charge. So the basic aim is that since this one is your process, right? So this process will be having a transfer function, right? So there is a controller, that is GC. If I am writing, that is controller, and that is the final control element, right? And this one is your output, and from here there will be a GM, measuring instrument, and there is your X, that is your set point, and this is your output. Is it clear? And let's say this one is negative feedback system. So what happens over here? There will be error here, right? This error is being generated. Why this error is coming? Since you have set some value of output. Let's say if the thing is that if I want to measure the temperature of this continuous state tank reactor over here, right? Let's say I have set a temperature of 100 degrees centigrade. But due to some particular region, some external, I mean, endothermic reaction is happening, and if temperature is coming to, let's say, 95 degrees centigrade. So this will create an error of 5 degrees centigrade. Now, what will happen? This error here is being entered into this GP process, and this controller will try to, reach this 95 to 100 degrees centigrade. That will try to control this temperature to reach the 100 degrees centigrade. This will give the signal to the final control element to do anything so that the temperature can be reached to 100 degrees centigrade, right? And once this final element do the control action, after that this temperature will give you the 100 degrees centigrade, that is the desired output. That's what the essence of the controller is. So that's why we use controller, means we are trying to reach to our ultimate value of the response what I want, right? So there are different I mean processes are there that requires a controller and all kind of thing. And on that basis controller has been defined as the three form. First is proportional controller, depends upon the use. So proportional controller, I'll tell you all these things where we use proportional integral and proportional integral controller. Second is integral controller, or direct I can write proportional integral controller. And third one is derivative controller, but I am writing proportional. derivative controller. That one is P only, that is PI, and that one is PID, right? So PID, let's say if I talk about PID, so this will be made of proportional, integral, and derivative controller. So depends upon the use. First, initially proportional controller was there, and after that, I mean, some enhancement was there in the proportional controller. That proportional controller was not able to control. So PI controller was introduced, and some enhancement in PI controller was there that PI controller cannot do. So PID controller was there. So I'll tell you all these. Use of where we can use proportional controller, where we can use proportional integral, and where we can use proportional integral derivative controller, right? So first, let's try to discuss about proportional controller, right? So the definition of proportional controller is the controller produces an output signal that is proportional to the error, right? Where error is key that I discussed right now. So what was there? This one is controller GC. So error was coming as an input. So the output of the proportional controller, let's say output is P, right? So this P is directly proportional to error. That is the definition of proportional controller, right? Is there any doubt? So your P is output signal from proportional controller, right? So once I'll remove this proportionality constant, so P will see that is Kc into E, right? So here Kc is equals to gain or sensitivity of proportional controller, right? And what is error? E is called as the error, that is set point minus measured value. And what is this measured value? So I told you that this one is something. So here error is getting generated. So this one is your output will come, some measuring instrument will be there, and this will come here. So this one is your x, that is called set point. And from here, what is what the value that is coming over here in the feedback, that is called as the measured value. And then this error is getting generated, and there is a controller GC, and after that this will give you P. So the error that is equals to x minus measured value. That is what I'm writing. That is set point, that is x minus your measured value, right? I hope these things is clear to all of. So here, what we have got that your PS is equals to Kc into Es. That is S in S domain. So this is your output of the controller, and this is your input. Since we know this is output of controller in S domain, and that is error, that is input to the controller in S domain. So can I write that PS divided by ES, that is output by input, that is equals to Kc, and this is the transfer function of a proportional controller, that is Kc. So you can see that is the transfer function. transfer function of proportional controller, right? Anyhow, and this is again, I'm writing all these same thing. But now here you can see there is a term KC that has been written over here. But in process industry generally, this KC is called as the gain. Already I have written earlier. But in terms of in place of KC in industry, you will see the term proportional band is used. That is defined as PB for the controller. Proportional band is used in place of KC in process industry, right? In terms of gain. So how can we define that KC? So the PB, that is proportional band, this is defined as the error required to move a valve. Already I taught you valve yesterday. Valve from fully closed to fully open. Alright. Means if there is a valve, yesterday I discussed these things. If there is a valve, right? So this valve is there in a I mean in a process industry, right? Now this one is right now completely closed. This one is fully closed. Now what happens? This in a process, what happens? This process will require to completely open, fully open to fully close to fully open. So during this particular process, what happens? Some error will be getting generated in a system, right? And that error is called as the E, and that is called as the proportional band, right? So this is a specific parameter that has been defined for a valve in a process industry to when a valve is completely closed or fully closed, and if we wish to open that valve from fully closed to fully open system, then at that during that process, the error that is being generated inside the process, that it will be called as the proportional band, right? That's what the definition of band is. So in the process industry, in a place of gain, generally some people use or some engineers use proportional band, right? Is there any doubt? And it has been defined as so it has been defined as proportional band is inversely proportional to gain Kc. So if Kc will increase, proportional band will decrease. Means range of error will decrease, right? Range of error will decrease in the process industry. Fine. So it has been defined as the formula for Kc in terms of proportional band, that is 100 upon proportional band, and this proportional band will be in the percentage. So this is the formula of Kc that relates a relation between proportional band and Kc. So if proportional band is given, you can calculate the Kc, or if Kc is given, then you can calculate the proportional band of that particular process. Right? Any doubt? So we saw that there is a Ps divided by Es, that is equals to Kc. That is the transfer function of proportional controller. So can I write that Ps that is equals to Kc into Es? So since this is in S domain, I'll want to convert this into T domain. So how can I convert? Taking